Hi, everybody. Welcome to Taking Android to Work. My name's Gabe Cohen. I'm the product manager for Android Enterprise. And I have with me Fred Chung, who's a developer advocate on Android, and Andy Stadler, who's one of the senior engineers on Android. We're going to talk today about enterprise mobility, Android's enterprise features, and how you can extend Android in the enterprise. But first, just a little bit of housekeeping, and you've been through this for many, many sessions now. You've got our links to provide feedback on the session, whether or not you find it useful, and also to submit questions via moderator. Of course, we'll take live questions also. So let's get started. As you've been hearing over the last couple of days, Android is growing very, very fast. There are hundreds of devices, hundreds of carriers, 400,000 devices being activated a day, and over 100 million device activations to date. But you might not know that it's also growing fast in the workplace. But why is that? You could point to that consumer growth as the source of the momentum, but how does it actually translate into workplace acceptance? Well, let's think back a second. It used to be the case that the IT department bought smartphones. They'd buy hundreds and thousands of devices, they'd set them up, they'd give them to the users, they'd support the users, they'd pay for the data plans, and so on. And then really good smartphones started coming out that were targeted directly at consumers, and consumers started buying the smartphones themselves. And some of those consumers, namely C-level executives at Fortune 500 companies, started demanding that they take those phones to work. Because nobody wants a cool personal smartphone and a lame corporate phone, right? But to make that work, a phone needs to do a lot of things. Whoa, I still got a printer update. That's amazing. Sorry. Anyway, in order to make that work, the device needs to do a lot of things. It needs to meet your home needs, your personal needs, your social needs. It needs to meet your work and your productivity needs. And it needs to meet the needs of the CIO and the IT department. Companies have a really big incentive to work with their employees to accept their personal phones because there's a lot of money to be saved in both the hardware and the data plans. So let's talk about how a company decides to accept a mobile platform. So let's put on our CIO hats for a second, and funny-looking glasses, bow ties, whatever, and talk about the main concerns a CIO has when accepting a new platform. So first of all, there's securing the corporate data from loss or from theft. There's managing new and more diverse devices at scale. And then there's apps, which is all about the CIO's responsibility to make the company more productive with new technology. So let's take a second and walk through each of these in a little more detail. So first of all, the CIO needs to make sure that the company's data is secure. And even an employee with the best of intentions is a threat to your data security, because after 4 drinks, he leaves his phone on the bar. And he probably doesn't read your memos that you send out about setting a password and a lock screen for your devices. Maybe he takes that phone to Starbucks and logs on to the corporate intranet. You better hope they're using SSL or VPN. And in the worst case, a competitor could find your vice president's home, break into her car, steal her phone, rip out the battery, put it in a Faraday cage. You get the idea. Secondly, the CIO needs to figure out the processes that are required to manage all these new devices, more diverse devices at scale, which means they need to set processes for the users. How do they know whether or not their phone's accepted? How do they set it up? How do they bring it online on the network and to the intranet, to the mail service, et cetera? They need to define security policies for the company or potentially for individual organizations within the company that have different security needs depending on the types of information they handle. They need to figure out how to support more users over time on different kinds of devices. If they have problems using the device, if they forget their password, which is extremely common, if they lose it. And then finally, over time, they need to keep a holistic view of the entire fleet. Finally, the CIO needs to make the company more productive with the new technology. And that means they need to look at the key software that their employees use. They need to look at whether or not there are mobile interfaces or apps available for that software, and then decide whether or not to build mobile apps for that software or buy them. And once they have the software, they have to get it to the users. How do they distribute the apps to those users' devices? And then over time, how do they maintain them? Cue fancy animation. And in some cases, they actually need to lock down the applications users can use on devices because there might be liability issues, with users consuming mature content or consuming lots of data that might come back in a corporate overage bill. They might also have regulatory issues they need to comply with. So now that we've looked at those three major areas the enterprises consider when deciding to adopt a platform, I want to talk really quickly about how Android actually addresses those needs. So Android is first and foremost focused on users. We want to build hardware and software that users lust after. We also want to build the ecosystem as big and as fast as possible because it pays all these dividends in terms of network benefits, right? We get more developers, we get more applications, more devices, and more user choice. But there's a lot of money being spent in the enterprise. Enterprises spend millions and millions of dollars on hardware, software, services, support, and so on. And there are actually a lot of users in the enterprise as well. Like a lot of consumers actually have jobs. And those are the users that we're focused on here. We want to unlock their ability to take their personal phone to work and use it for both purposes. But it's really important that we keep the enterprise support that's in Android open and extensible because we want OEMs and software vendors to go out there and make money in the enterprise today. And they're actually doing that. If you look at Motorola, they released an enterprise-focused device, the Droid Pro, has a better keyboard for business usage. You can look at NitroDesk. They released Touchdown, which is a drop-in Outlook replacement, essentially, for your phone that's available in market. It's extremely popular. One of our partners, MobileIron, actually has added Android support to the platform, to their mobile device management suite. So we have a lot of partners out there doing different things, and especially when you look at the OEMs and the carriers, they're doing a lot of interesting things and moving potentially in a lot of different directions. It's a good thing because they're out there actually getting devices into the workplace today. But Android actually needs to introduce standards over time into the platform so that the enterprise features that are there for the developers are exposed in a consistent way. So next I want to talk just briefly about the features we've actually added to the platform over time. So way back in Donut, we introduced some of the first relevant features, secure Wi-Fi and VPN support. In Eclair, we added basic Exchange support for email and contacts. In Froyo, we completed the Exchange support by adding Calendar. And then we added a really important piece we're going to talk about, again, in a minute, which is device policy management, which is about setting up security features and requirements for the phones. In Gingerbread, we added more productivity features into Gmail and Calendar and contacts. And in Honeycomb, we added some really interesting stuff. We added more security policies that control passwords. We added support for device encryption, which is one of the most frequently requested features we've been getting from enterprise customers. We added global address list support across the suite of apps and in contacts for both Exchange and Google Apps. So that's kind of an overview of how Android is approaching the enterprise, the features that we built, and how we're prioritizing things. And I hope that's been useful to you guys. So next I'm going to hand it over to Andy Stadler, who's going to talk a little bit about device policy management framework. Thanks.
Okay, thanks, Gabe. Okay, hi, my name is Andy Stadler, and I'm going to sort of address the fact that this is a developers conference and dive into a little bit more of a development topic, actually. And that is how you as developers can tackle one of the problems that Gabe touched on, and that is how can your app ensure that it is running on a secure device, or how can your app control the aspects of your device configuration to make sure that it is in a secure environment. Now, what kind of apps need this? I've kind of broken it down into three really broad categories. The first is apps that are really the client endpoint of fleet management solutions. And I've listed a couple here that you're almost certainly familiar with. These are the apps that provide an administrator with the ability to control and monitor the security status of a whole fleet of devices. Now, some apps don't work with a server, but they really need to also provide the assurance that they are on a secure device and that the data that they're collecting or presenting is safe, it remains safe, and is presented only to the intended users. And finally, there are apps that provide device management or fleet management types of capabilities, but they are really oriented towards single users. Now, these are really just a loose collection of overlapping suggestions. There are plenty of other kind of interesting ways to deploy and use these devices. And our challenge was to enhance the Android framework in a way that could support applications like these, applications you can come up with, and most importantly, support multiple applications. We've always believed strongly that Android apps need to coexist peacefully with each other, and security-oriented applications are really no different. So in order to support applications like the ones I've described, we developed the Device Policy Manager. And in the next few slides, I'm going to show you what it does and how you can write apps to use it. So the first thing to tell you about is policies. And these are the actual specific controls that an app can place on a device. So you're very familiar with policies, things like require a screen lock password, require the device to be encrypted. These are policies. We introduced policies in Froyo. We enhanced and added to them in Honeycomb, and we are going to keep on adding policies as releases continue. And if you want to think about where the roles involved, there are really these roles. Applications that you write are going to set the policies. The Device Policy Manager is the APIs and the framework for maintaining those policies and communicating them among the various modules. And finally, the rest of the system is supposed to obey the policies. Now, let's look at one sort of interesting aspect of this, which is what happens when you have multiple apps that are trying to control policies. When there are multiple sources of security policies, we need to consider what I call the principle of increasing security. Any app can make or set policies that increase the security of the device, but no app can use policies to reduce the security of the device. Now, in practice, this really just boils down to a simple set of rules for each policy. So for example, passwords need to keep getting longer and stronger or more complex. And things like a screen lock timeout would get shorter and shorter, which makes for a more secure device. Now, you might be wondering if the policies I'm describing, or the concept of policies, is really just a different version of Android permissions. And they're a little different in a subtle but important way. Permissions they basically let your apps do things that are risky or maybe costly or might expose data. Policies, on the other hand, actually increase the security of the device. So the more policies you're moving in, the more secure direction. Okay, anyway, now with these policies in place, we just have to define an API and a workflow for using them. Now, in order for you to create a policy management application, you need to add the following 3 elements. The first is that you need to explicitly define the policies that you're going to enforce. The second is you write a receiver. This is very similar to a broadcast receiver, and this is so that you may be notified of the changes to the device security status. And third, you're going to write a policy controller, and this is where you actually write your own code which interacts with the Device Policy Manager to monitor and control the security status of your device, and also to enforce whatever business logic is associated with that security. So now we're going to take a look at a sample implementation. We'll start with the policy declarations. And this is simply a list, like I said, a list of the policies that your app intends to enforce. And each policy directly corresponds to one or more API calls. If you don't declare the policy, you may not make these calls. And we're going to see later that this same list will be shown to the user in a system activity. But of course, it'll be formatted quite a bit more nicely. And the next thing you're going to implement is a receiver. And this is where your app can be notified of changes to the device security state. I added one little note here because this is one of these things that, just one of these general Android programming reminders, is that notifications come in on the UI thread. We always have to be careful and not get ANRs and things like that. But the most important thing is this is where you learn about the changes to the device status. And a little later, we'll talk about the things that you might do when you respond to these. Okay, so finally, we're going to implement a policy controller. And this will take a few slides, but we'll walk through the pieces of a sort of a sample typical policy controller. And in this case, it's going to be one that requires a specific policy for your device that the user must have created either a PIN or a password for their screen lock. So the first thing we need to do is find out if our app has even been activated as a device policy administrator. And if our app hasn't been activated, we will not be able to make any policy calls at all. So the next step is to ask the user to activate our app. And this is a place where policies are like permissions. They are always exposed to the user. The user sees them and accepts them before we can proceed. We don't allow just any app to start enforcing policies on the device. So when you make this start activity call, it presents a system activity which explains to the users what they're about to authorize. And the app only receives permission to assert the policies if the user clicks activate. Now, even though this is a system activity, your app does have a chance to insert some text, which gives you a chance to tell the user what's about to happen and why. And by the way, the user might hit cancel here. What do you do? We'll talk about it a little later, but the simplest thing to say is that you need to be ready to keep trying. If you need to get your device to a secure state, you need to be able to retry this process until the user gets there. And obviously, you're not going to want to present the secure data or make the secure connections or whatever it is that your app does until they get through all these steps. Now, once we have been activated, we can start working with the specific policy APIs. This next step highlights an important concept, which is that there are many policies where just because you've set a policy, it doesn't actually mean the device has become more secure. So for example, in this case, we can set a policy, we can require the user to enter a PIN or a password. But until they actually go through the process of entering a PIN or a password, the device isn't really as secure as we want it to be. So here you see in this code, the first call sets the policy, and then the second call asks the question, has the user done what they need to do to reflect the policies we've set? And in the case that they haven't done it yet, we need to, again, set the policies we want and do what we need to do to get the user to make the changes. And in this case, we're going to use standard start activity call to send an intent, launch the settings screen where the user can enter a new PIN or password. Now, normally, the user can choose from 4 types of screen lock: none, pattern, PIN, or password. But now, because we've established a policy, the user will only be allowed to choose a PIN or a password. So this is a direct example of the policies that you've set affecting the behavior of the system. Now, once again, this is a place where the user might not continue. They might hit back or home or get a phone call, or in any way they don't get past the step and they don't finish creating a PIN or password. So once again, this is one of those places where you need to be ready to sort of restart or deal with this. Now, before we wrap up, I would just like to cover a few issues that are pretty important when you are developing device policy applications. First, as I've been mentioning before, there's no denying that it does take a few steps to get through the process of getting a device to a sufficiently secure state. You need to account for the fact that the user might not get through all the steps the first time. And your policy controller needs to be able to restart the process at any point in the sequence. And your design should focus on moving the device step by step towards a sufficiently secure state. So to use an example in the platform email application, where we walk through this exact same set of steps, anytime the user exits before the completion of the sequence, we post a notification that says there's a security steps are required. But then we just leave it there, let the user respond to the notification, and at that point, bring them back into the sequence. The other thing you might consider is through the use of dialogues or other ways of communicating with the user, tell them what they're about to do. Because, for example, if you just suddenly present a password entry screen, they might not understand why. So dialogues, notification text, these are all your friends here. Next, there are going to be times when the security level of the device actually decreases. An example here is that some of the newer policies we've added allow you to set device PIN codes or passwords that have expirations on them. These are designed to force the user to enter a new one, say, every 30 or 60 days. Now, if they allow those codes to expire, your device is not really secure at this point because it's using an old code. So the device is now at a less secure state than your app wants it to be. However, it's really up to you. Again, this is a business logic question. It's really up to you what to do at that point. And finally, if you are implementing account-based policy applications, and if you support multiple accounts, then you're going to be partially responsible for the increasing security notions that I described earlier. Make sure you don't let any one of your accounts reduce the security levels that was required by any of your other accounts. Now that I've covered the things you need to do when you implement a device administrator, Fred Chung is going to show you a demo app that actually walks through a few of these steps.
Thanks, Andy. Hello, everyone. I'm Fred Chung. I'm a developer advocate on Android. I work with a lot of external developers, and my focus area is enterprise. Well, Andy just talked about the detailed implementation of the Device Policy Management API. In this section, I'm going to do a demo that shows a practical application of the API. The use case is actually pretty straightforward. We are trying to enhance the security of an internal application. Well, by internal application, it can really be referring to any applications containing sensitive information. Well, for example, your HR application, well, it contains my salary information. I really want to secure that kind of information. Typically, those applications may already have an app-specific password requiring users to authenticate. Here's the problem. Can I see a show of hands? How many of you have your screen lock password set up, including the device you got yesterday? All right. As it turns out, more than half of smartphone users don't have their screen lock set up. For those of you that didn't raise your hand, I urge you to please set it up after the session. So back to the demo. We're trying to perform a demo that's aiming to enhance the security of the application by ensuring the proper screen lock is set up. Well, before diving into the demo, let's have a quick overview of the high-level architecture of the application. As you can see on the screen, in the middle is the Android client in a tablet form factor. On the right is an admin server that's sitting somewhere in the cloud. For this demo application, the admin server is built on Google App Engine for Java, but in reality, it can be based on any technology stacks. It doesn't really matter. The admin server exposes a couple of interfaces. It exposes an HTML administrative interface, allowing system administrators to go in and define security policies. And what I mean by security policies is that they can define things such as what's the minimum length of my password, does the password have to be PIN type or alphanumeric or pattern, so on and so forth. Now, the second interface that is exposed by the administrative server is a web service interface in order to facilitate two-way communication between the Android client and the server. OK, let's jump right into the demo. Right here is, I'm using this laptop to access. Oh, I'm sorry, can we switch to demo?
You're on.
You got admin up.
No.
All right. Can we switch back to demo, please? On your right, I'm looking at my admin server through Chrome browser. And right here, I am working on a Motorola Zoom, obviously running on Honeycomb. And this icon here is the demo app. Let me go to the admin server first. I'm going to go in and log in as a user, a test user. All right. I'm looking at the administrative interface. It's a pretty clean UI. It is an admin interface allowing administrator to go in and define security policy. Let's go ahead and set up a test security policy, say requiring PIN of minimum of 4 digits in length. I'm going to go ahead and save it. Now it's persisted to Google App Engine. Now I'm going to go back to the Android client right here. Before launching the app, I want to just say that when you launch the app, it's going to present you with a series of setup steps. Here's the first step. It contains a bunch of instructions, basically telling me to go to the admin server and set up a security policy. Since I've already done that, I'm going to go back to the Android client and click Next. Now it shows me the list of accounts that already set up on the device. And I'm going to just go ahead and click on the one account that I have set up. Now, the app is about to perform a number of steps outlined in Andy's section. In reality, those steps will probably complete within a fraction of a second. So, and therefore, in order to make this demo more meaningful and make this demo easier to follow by everyone, we have deliberately introduced a number of pauses requiring human intervention in between steps, just to make sure the concept is clearly communicated across. The next step that I'm going to perform is to synchronize the security policy from the server. It's syncing through 3G network. I'm glad that it works. So it came back. It brought back with the security policy that we just set up, as you can see, with PIN and a minimum password length of 4. Notice the 2 question mark icons. Those icons represents the fact that at this state, the application doesn't know how to deal with the security policy because it hasn't been activated as a device administrator. And I'm going to go ahead and do that next by hitting on this button, Activate. It then triggers a system dialog box. And as Andy also pointed out earlier, that in this system dialog box, you can put in some customized message to make it clearer to the users what they're dealing with. Now, at this point, there could be multiple outcomes, right? The users could click on Activate, or they could click on Cancel or Back, right? So when you're building similar application, you just need to account for different possibilities like that. Now, let's go back to the Activate screen. OK, this is the same screen that we just looked at, and let's now go ahead and activate it. Now, the application's been activated as a system administrator. And as you notice on the icons, for the icons, they switch from question marks to exclamation points, meaning that the existing password, which doesn't exist on this device, the existing no password set up on this device actually is not sufficient as per the device policy. And therefore, it's presenting me with this Enforce Password button, OK? And I'm going to click on this, which then triggers another system intent to cause this password change screen to appear. If you remember, we defined a security policy requiring a PIN type of password. You notice how these selections of not secure and patterns are disabled because these are deemed less secure than what's being required by the security policy. Let's go ahead and set up a PIN type password of, I'm not telling you. OK, now I have set up a PIN, and the device recognizes that, OK, the existing password actually is sufficient for what's being defined by the security policy. And then I can actually go ahead and access my security, my sensitive content. OK, now that the device is properly set up with a screen lock password, and I'm going to show you what additional security can be provided by the administrative API in conjunction with cloud-to-device messaging. And for those of you that are not familiar with that, cloud-to-device messaging is Google's implementation of push messaging. So, and one of the criteria that Gabe talked about in his talk, CIOs need to really care about device loss, theft, right? In the event that that happens, they need to have a way to be able to remotely control the device or remotely limit certain access. And that's what this next part of the demo is about. Let's go back to the admin server screen and navigate to remote admin interface. There are 2 buttons. OK, I'm going to just go ahead and click on Lock Device. What happens after clicking on this is that it's going to send a push message through C2DM to the device, and the device should react to it by locking up the screen. Give it a few seconds.
Show your hands.
Oh, and of course, it's not working. Let me give it one more try. Well, it's not working, but I hope you get the idea. All right. Can we actually switch back to presentation mode, please? All right, that's too bad, but trust me, it works. Let's see. So that concludes the demo, right? At least part of the demo, where we just looked at a proof of concept on the kinds of device management capabilities that are possible. What we just looked at is open source under Google Project Hosting. I strongly encourage you to have a look at it. As developers, you can further expand on this kind of capabilities by incorporating more useful features such as remote wipe or password resets. Now, let's switch topic a little bit and talk about a different thing. One of the criteria CIOs consider is how to get apps to users' devices. And let's talk about that in the next section. All right. Well, you may consider, the system administrator of a company may already have a collection of Android apps that they want their users to install. Well, some of these apps may be homegrown applications that are highly proprietary to the business flows of the business. Another types of apps could be coming from third-party applications that are publicly available, and these types of applications are aimed to increase the productivity of the workforce. For example, touchdown clients, or documents to go, or Angry Birds. Or the last one may not make sense, may not be such a good idea for certain businesses, but I hope you get the idea. For these types of publicly available apps, right, you may want to direct your employees to Android Market. Let's see. Okay, well, Android Market is a great distribution vehicle for distributing publicly facing applications like what we just talked about. All you have to do is to direct your users to a URL of this format by including the package name of the apps you want them to install. Using Android Market, it gives you, a number of very useful features at no development cost. Just to name a couple, hosting. Hosting is something that you don't need to worry about. Also, any app updates are automatically made available to the clients automatically. However, internal app distribution may require different solutions because, well, in some occasions, it doesn't really make sense for others to see your internal applications, or you simply don't want others to know the existence of certain private apps. I'm going to show you two commonly used approaches to distribute internal apps next. Well, let's first have a look at site loading. And I'm sure in the audience here, the majority of you should probably know what it is. It's actually pretty straightforward. One pretty common implementation is to host the APKs on a server. Right? It can be any server capable of serving files. It can be Apache, or it could even be based on Google Sites. Works pretty well, too. To install apps, users just need to point their browser to the URLs, or by simply clicking on a hyperlink. When the download completes, user taps on the APK, then the standard app installation screens will take over. I also want to point out that in order for site loading to work, you need to make sure that the unknown sources selection under settings is checked. And since Android is an open system, right? Different OEMs or carriers may choose to do different things. Some have chosen to disable these settings altogether. And in that case, side loading may not be possible on those affected devices. I just want to make sure that people are aware of that. Now, we talked about side loading just now. With this approach, as you can imagine, as your usage grows over time, which, by the way, is a good problem to have, it may become a little hard for your employees to manage all the URLs that they are given. Or sometimes they may get all the URLs, all the updates mixed up. In order to circumvent this, I'm going to talk to you about a more sophisticated approach, which is what I'm calling internal app directory. Let's have a look at an overview of what this internal app directory is all about. In a typical deployment, it involves a piece of server software and a corresponding Android client. If you look at this setup, it's not that different from the demo setup that we just saw. Through an administrative interface, system administrators can publish a bunch of apps that they want to be made available to their users. Periodically, the Android app would check in and say, hey, give me a list of apps that my user can install. the list would then get displayed on screen. And at this point, the Android client can perform a number of validations. For example, you can check whether the list of apps already exists on the device, and if so, flag the user appropriately. And if you need to build this kind of solutions yourself, I strongly encourage you to just bookmark this API doc for Package Manager. This API, this class exposes maybe a few dozens of methods that allows you to gain visibility into the various packages that are already installed on the device. Just to name a couple, this API gives you visibility to the kinds of applications that already exist on the device, and get package archive info allows you to do something like to check the validity of a downloaded APK and stuff like that. So when the user chooses a particular app that they want to download, the actual download of the APK happens, and it may get stored in external storage. And lastly, when the user clicks on it, you can fire a system intent to trigger the installation flow. Well, as you can see, this is a pretty involved method, but over the long term, we believe that if you wanted to invest in this kind of solutions, you could build something like this yourself, or you can purchase some existing solutions out there in the market, and the functionality are pretty similar, actually. Well, I wanted to close with sharing a few resources related to what we talked about today. We are excited about Android's momentum as a team in the consumer space, obviously, and also in the enterprise sector. In the enterprise sectors, well, we know that we are not there yet. We have some more work to do, and our team is actually working pretty hard in order to make sure we become successful in this area as well. Lastly, for developers, we are looking forward to seeing the kinds of innovations from this audience right here, and we hope that you can build a pretty healthy business and be very successful in the long run. Thank you very much. So if you have any feedback, please provide us. We'd love to hear your feedback through this URL, and I'm going to open it up for Q&A. For those of you that are watching
I think we can pop up
the stream, the live streaming, you can use the Google moderator for Q&A.
Who's broadcasting that?
I am. We got it on the screen.
Oh, okay. You should put it on presenter view.
Yep. Just make that a little larger.
With the green. Oh, yeah.
Okay. Let's start in the crowd. First question up front.
Are there any plans to implement user accounts? Say, different users could log in with different passwords to a tablet, and different applications would be enabled based on that user's profile?
I can take that. That's something we're thinking about. I mean, when we first started building Honeycomb and thought about the tablet use cases, like passing a device between users on the couch, it became apparent we might need something like that in the future. We definitely also get a lot of questions about people, again, in this dual use scenario, having different security requirements, not wanting to impose the harder security requirements to access their personal stuff. And then, of course, in the worst case, what happens when they leave the company, what gets wiped. So we're thinking about that, but no specific plans.
Thank you.
Yeah. Maybe from the back, Mike?
Two questions. One is there any way from an application to detect that a device is rooted?
I believe there's a programmatic way that I've seen once on Stack Overflow, actually, but I don't know off the top of my head what that approach is.
Oh, you've seen some app that has managed to do without asking the user any questions, right? Because the user will obviously say, no, it isn't rooted, because they want access to enterprise resources, so they won't give me access.
They won't give you access?
They won't give me root access, to figure out whether the device is rooted or not. But
Right.
in this case, the user is the enemy in some sense.
Yeah,
the app, because the enterprise wants
I totally understand the question you're asking, and it's an important question. I don't think any of us can answer it.
I think that's a question best targeted at our security team in case they have ideas, and it may vary from device to device also.
Yeah.
Okay, and the other question was, are you planning to support certificates for Activesync?
Yeah, that's actually one of the questions in the moderator queue. We've been hearing that pretty frequently. Also, we've noticed that users have had a number of setup problems because we don't support certificate authentication in AOSP Exchange today. So that's something we're actually working on.
Thank you.
So I have a question about the suggested method for using the what you call the internal app. So
Right,
it sounds
app
like
directory.
it sounds like Google doesn't have a solution, so you're just asking the developers to come up with their own distribution mechanism. But it sounds like that's still going to require side loading to be enabled, and that doesn't work at all on AT&T phones. And I don't know on other carriers in other countries whether they enable side loading or not. So
Right.
And in many ways, to ask people to enable side loading kind of means less security to them. So it seems counterintuitive that you would do it that way. So is there any plans to incorporate some type of enterprise type of market in the future?
Well, good feedback. I think we can take that back and look into that further.
I mean, we're definitely aware of those problems. We're thinking about it, but I don't think we have any solutions right now.
Okay.
Yeah.
But then it would require side loading through that mechanism, right?
That's right.
what
That's
it
correct.
currently does.
That's going to be the mechanism. Yeah.
Okay, thanks.
Yeah.
One of the things that you didn't mention about the device admin is that once you enable it, you're unable to uninstall the app. Can you explain what the motivation is behind that and why it's not documented?
Well, I'll answer the second one first. Anything that's not documented is certainly not intentional. And so, we welcome your feedback on places where you're finding things missing in the documentation. I think that's a fair statement on any API. Now, in terms of why you can't uninstall an active administrator, the answer is quite simply because this is something that has made assertions about the security state of your device, and to simply uninstall it would be to drop everything. Now, the good news, however, is that you can deactivate an administrator app, at which point you can uninstall it. And when you deactivate it, that's one of those callbacks I mentioned. And so, for example, when you see that you've been deactivated, that's one of those regressions in security I was talking about. If you're protecting data, that's the time to wipe it or whatever.
Right, but there's no security preventing someone from deactivating it. So it just seems like it's an extra checkbox a user has to uncheck. It doesn't actually make it impossible to uninstall or anything like that. It's just an extra hoop you have to jump through first.
It's more than an extra hoop. It's very explicitly a notification. So the question is really then one of, are we going to block it forever, which I think is what you're suggesting, or are we going to allow the users to do that change, but at least give the apps the notifications they need? And the choice was made in the framework design to take the latter course, which is we're going to let the users do this. This is, again, one of these things where it's the user phone versus the corporate phone. And the current direction is that the user still has the control of their phone. So we make sure that the corporate data has an ability to detect that some changes are happening and protect itself in whatever way is necessary. But we're not currently going to block that change entirely.
Okay, the current error message is just uninstall failed. It's not very useful.
Right.
I'm not surprised.
Thank you.
We're
Thank you for that. That's very good
request
feedback.
for
Thank
that.
you.
Let me take a couple of the moderator questions we have up here. The first one I don't have a great answer for. Are there plans to explicitly support remote control apps so enterprise IT can solve problems directly on employees' phones? I think the answer is today, I've seen some vendors in this space actually partner with OEMs to expose the APIs they need. For instance, one of the APIs I've seen requested by people who do this kind of support is, I need to screen cap or actually remote control, like super dangerous permissions that we haven't exactly figured out how we're going to expose, like if they would be in market or what have you. So we're thinking about this, but don't have any direct solutions today. I think in some cases, a lot of our partners go to OEMs to accomplish specifically what they need, and then if they're really bold, they try to create standards, across the OEMs. I think we still need to figure out which are kind of the most common features we need to support remote control, and then ultimately, we'd like to incorporate them into the platform. Assuming that the user's informed, that they give consent, and that it doesn't, neuter sort of the user experience. So for the second question up here, let me jump down. are the plans to implement a VPN Provider API at the platform level so different VPN types could be installed through the market. This is also a case where people are solving this problem today by going to OEMs. I think Cisco has an OEM partnership to provide one of their VPN clients. There are a few others. I know the Droid Pro packages something else. What we'd really like to see is that any vendor has access to the users via the market. Again, VPNs are extremely dangerous because they can basically monitor all network traffic when they're active. So we're actually working on coming up with a solution that allows these types of things to exist in user space, to be distributed through market. But working on the usability and the experience is kind of challenging for something that's so dangerous. We need to make sure there are a lot of hoops to jump through, not unlike a device management agent. So maybe back to the mic.
Yes, hi. Is there any way to push configuration on the phone, like VPN settings, for example?
We're definitely thinking about that in conjunction with working on improving VPN support, but nothing specific.
But aren't some of the third parties showing some things along those lines?
Oh, I know that some third parties, again, have gone to OEMs to get APIs or are using private APIs because they've been sideloaded with root privileges by OEMs to do remote configuration. I actually think this is one of the most important areas that's going to be the most common across devices that we'll need to tackle in the future. But we're not quite there yet. Yeah.
Hi. If a company wanted to start using your device manager API for internal applications, they would want to ask questions about what tools you have so we can test the application to be sure they're actually secure.
I'm sorry, what's the question?
Yeah.
What testing tools are available?
None that I'm aware of, but maybe you can tell me what you had in mind and we can start to look at that.
A lot of companies will have like a corporate IT policy that this has to go through some kind of penetration testing.
I see.
No, I don't know that we necessarily have any vision for best practices for penetration testing of Android apps. Might be an interesting question for security team also.
Yeah.
Yeah. Sorry.
We'd be glad to get more information from you after this session.
Next, Mike, question.
Yes, are there any plans to add the programmatic ability to add certificates into the certificate store? Because currently, if a certificate has a CA that isn't built into the Android OS, that presents a bit of a problem.
Yeah, and so I know Gabe mentioned earlier, because we had another question about certificates, and really what we are in fact working on is we didn't want to just jam certificates into one app. So there is underway basically a more integrated solution for dealing with certificates, and the things like you're talking about are definitely part of the workflows we're looking at.
It's a known requirement. It's not one certificate. It's many certificates in order to bootstrap an email client. So yeah.
Okay, thanks.
Sure.
I have two questions. First one was, in the first part of the demo, you had some policies applied to a specific user account. So I guess that implied that you could have different policies for different accounts. Is that correct?
Yeah, I mean, I think that it was, what he was showing was an example where the server would be tracking multiple accounts,
Right.
not the device.
Not the device.
Right.
And the second one, can you, so you compared policies with permissions. It's possible to create custom permissions. Can you do that with custom policies? Like, can an application define a custom policy?
No, and the reason is because the policies don't work. They don't really matter unless they have some teeth to them. So the policy, you can't just say, I want to make a new policy. You've got to have the rest of the OS obeying that policy. So really, the policies kind of come from the bottom up. A particular piece of the system will, the thing I didn't describe in the device policy manager is there's two tracks of API. There's the parts that apps would use to assert policies, and then there's the parts that the rest of the system uses to say, well, what are the current policies? What do I need to do? And so an app coming up with a policy won't really help unless the system is watching for that policy.
But if say I'm employed by a device manufacturer, so I have the ability to do the other part of it. So I don't know, how would I implement something like, I only want certain users to be able to change any settings, for example?
I see. Well, if you're working for a device manufacturer, of course, you have the ability to add methods to APIs. That's obviously a capability you'll have. Then you would be talking about writing apps that would only be able to talk to that. So you'd probably want to use a shared library to distribute for those devices. I mean, these are the things that are fairly standard in terms of how OEMs can add functionality to specific devices. Nothing really special here. The main issue is, again, a policy doesn't matter unless somebody's listening to that policy, and I would obviously suggest starting there.
Thanks. Yes?
If a user enables a policy, say on a Froyo phone, and the app declares something like encryption, which doesn't exist yet, is the policy granted when the user upgrades? And if it's not granted, does the user have to activate again? Or if we upgrade our app to add a new policy, do they have to walk through that whole process again?
No, in fact, that's a really great question because you've actually noticed one of the subtle but important distinctions is that when we present the list of policies to the user, we do in fact list them explicitly, and when they hit activate, we basically in the system we copy down which policies the user accepted. Now, so for example, I think you hit a perfect one, which is encryption. Let's say they go through that on a Froyo device, and then that device is upgraded to Honeycomb, or Ice Cream Sandwich, or something. The user has only accepted the original and smaller set of policies, and if the app was upgraded to request some newer policies like encryption, it's going to continue to run just fine until it tries to assert the encryption policy. So it's going to be bounded within the ones that were accepted. However, there is an API. I didn't show it in the sample code, but there is an API where you can basically look at policies on a one-by-one basis. You only need to use this if you've upgraded that policy. And you can say, oh, do I have this one? And if not, then yes, you do have to loop back and have them accept it one more time. Because it really, I mean, you can't just go do something based on this smaller set. You got to show it to the user and say, I need you to give me the okay to do this.
And does the user have to accept all the policies again?
Yeah, it's an all or nothing. There's no checkboxes or anything like that. Yeah.
From Mike?
I have a question. If the application is active, can it actually lower the requirements for security? Example would be, for example, email application. If you add the Exchange account and the admin requires it, if you remove the account, it doesn't actually lower the policies.
So what happens is that, remember I mentioned how there's policies and then there's the state of the device.
Yeah.
And they're linked, but they're not 100% connected. So to walk through a typical example, let's say that you add an account that requires a password. The user enters the password. You've done all the right things. Now you've got a device in that state. Now if they delete that account, we do all the right things, we delete the data that's associated with that account, we're going to release those policy assertions, but we're not going to actively change their password on them. So now the device is in a state where it has a secure setting, such as a password or a short screen lock or whatever, might still be encrypted. But if the user happens to go back to the settings for that setting, for that device state, they'll see that they've regained the ability to reduce the security on their own. At this point, it doesn't matter because we no longer have the accounts in place.
I was testing it on tablet, and actually, after removing account, it didn't allow me to remove the PIN.
Okay, well,
So
either
I guess that's just the bug.
it's either a bug or there was some other source of policies. So, like for example, I know when I've been working with policy code, and by the way, I should have mentioned this in the standard API demos, which is our sort of sample app. We have a whole page where you can manually set and control policies. And sometimes I'll use that when I'm exploring policy issues. And sometimes I'll forget that I left a policy asserted in API demos, and then my other app doesn't work right. That might not be what happened to you, but most commonly that's the case, unless there's a bug. Most commonly it's that somebody else is setting that policy.
This was just the built-in mail application.
Okay.
And the second question, talking corporate, any support for proxy?
Yeah, so we implemented it in 3.1, although I haven't seen that information publicized anywhere, and I'm hoping it actually made it into the release. I think it did. So I believe it's there in 3.1, basic proxy support, although we don't support auto-configuration or authenticated proxy, so it's not done. And actually, it's a little more nuanced than that because Android apps can use different network stacks. That proxy is applying to browser and apps that I believe use the Java networking stack.
Don't look at me right now.
Look, Andy, come on. But not necessarily everything. It's possible to bypass that, use lower level networking, and then you don't actually integrate with that proxy support. So we're still thinking about how to complete that. There's actually a question in moderator here also about that I was going to talk to. We also need to think about how to manage proxy support, but that's fairly dangerous in terms of application control of the system proxy, because again, that allows monitoring of all network traffic.
Is it then implemented per connection or system-wide?
It's per Wi-Fi network access point.
Okay.
Yeah.
Thank you.
Yep. Maybe back mic?
Yeah. Quick question. Is there any plan to implement the way that the application are pushed from the website, the Android market website, from something that will be agreed upon? I'm thinking about Google Apps for domain, for business. Once the policy is agreed with the device, can the admin push directly apps to the devices that he has the right for?
That's something we've actually talked about. It seems like that would be useful as a feature, although we haven't actually come to agreement on how and if we should expose something like that. Again, security considerations in mind. But it's something we're thinking about.
Okay. Obviously, yeah, it has to be secure, but once, because for the device that are linked to a Google app for business domain, there's already a lot of policy that you can wipe directly from the console. So I was thinking from this part of the domain, push app from here.
Yeah. Mm-hmm. One thing I want to just mention is that every time Gabe says we're thinking about something,
it's done already.
he really means it. His job is to maintain a very long list of priorities
and I sit in a cubicle and I think about them.
And feature requests that all of you have been, believe me, we know all of you have been asking for, and it's one of Gabe's responsibilities is keeping track of that. So when he says we're thinking about it, we really have had many discussions about it. I want to let you know.
That particular idea I think could be a really great end user experience. So it is a good idea.
As a user, during the week, I may have a bunch of applications that have very high security demands. But on the weekends, I might want to not use these applications and have lower security requirements, like not having to put in a password every time the lock screen comes in. Mm-hmm. Now, at the moment, I can set that up on Friday night. I can remove these applications or remove the security and reset it up on Monday morning.
You can factory reset every week, too. But.
Yeah, sure. Would like a Go secure mode or a per application model be more appropriate for that kind of user?
So there's a few interesting things we're seeing in the marketplace, actually. If you drop by the Enterprise booth, they're doing something kind of interesting today to address sort of this sort of dual profile scenario. It kind of gets at the earlier question we got about profiles, too. Yeah, don't really have a great answer for this today, but I think it's a real requirement. Yeah, we've struggled with this when we're enacting one policy for Google users on Android devices. What kind of passcode are we going to require in the interaction between, our multi-factor authentication, our device passcodes? It's, you want to work with the IT admin to come up with the minimum acceptable security requirements. So, because users see this for everything,
it drives them crazy,
and it drives them insane. You want to make sure that you sort of minimize the impact while maintaining whatever your minimum security requirements are. Most people don't really, we had this great conversation about the entropy differences in terms of security between a certain length pattern and certain length pins. And if you think through it really carefully what your real security requirements are, potentially you can lower that so it's not quite as painful.
Well, you'll never get agreement with the security IT guy and the guy on the weekend. Your own data showed that most people weren't locking their screens.
It's true.
Right. So, thanks, guys.
Cool. So I think
any more?
we need to wrap up. Let me see if we've addressed some of the other moderator questions that are here. I think we've talked about the need for unknown sources. We addressed that. I talked about proxy. We talked about VPN specifically, and to this question of, device manufacturers basically extending enterprise support. We think this is a really great thing because people want to use Android for work now, and if they really want to do that, they can buy a device that meets those needs from a manufacturer that's added those capabilities. Our obligation and I feel my personal responsibility is to look at what the OEMs are doing, to find the things that are going to be the most common, and make sure that those are baked into the platform, because we don't want an app developer who's talking to device management to have 5 different APIs they have to deal with for the leading OEMs to control something like device encryption. So we're trying to introduce standards over time. Like we introduced encryption in Honeycomb as people were starting to add it on top of Froyo. So.
And Honeycomb encryption is a good example, actually, because we knew how to encrypt the device, but we also knew that a lot of other OEMs were also working on encrypting devices. And so really, and it's funny, we get questions like, well, how many bits is the encryption? And really, the answer is it just needs to be really secure, and you all know what that means. But the important thing for us is there an API for it? Do we have an API? And does that API really clearly describe, we are going to encrypt at least this much of the data on the phone, and therefore any OEM can wire up their encryption system to that? That's important because that's what reduces fragmentation, not putting down a bunch of mandates about, you must have this many bits or, blah, blah, blah.
Yep. So, yeah, we plan to control these things basically through AOSP APIs.
Yeah. All right. And we're out of time.
Okay.
Right. And we're
Great.
out of time.
Thank you very much.
Thanks.